Today we're continuing our lesson on graphing inequalities in two variables on a coordinate plane instead of a number line. And the first couple problems we're looking at today have only one variable in them. And so that's going to make for straight lines to graph. So for our first example, we have y is greater than or equal to -3. Now remember that when it's y equals, we're looking at a horizontal line because it has a constant y value. It has all of the points that have a y value of -3. That's what all of these points have in common. So that gives us a horizontal line through -3. And since we have greater than or equal to, we remember from yesterday that we're using a solid line. The question is, do I want the points above or below this line? Well, where are the points that have a y value greater than or equal to -3? They're all above the line up here. All of these values have a y value, or all of these points have a y value greater than or equal to -3. So that's our solution area. All of the points down here have y values smaller than -3, so we don't want those. How about when x equals, or x is greater than or equal to a number? So we have x is less than -1. Now remember that when we have x, we're looking at a vertical line, okay, because it has constant x values of, in this case, -1. All of these points have an x value of -1. That's what gives us a vertical line. Now, since it's less than and not less than or equal to, what do we have to change about our line? That's right, it needs to be dotted so that we know we're not including points on that line, because points on this line have an x value equal to -1, and we want points with an x value less than -1. Now, where are the points that have an x value less than -1? They're over here. All of these points have x values less than -1. So this is our solution area over here. So that's how we graph inequalities with one variable in a two-variable situation. Now, let's look at a word problem. You have 2 summer jobs at a youth center. You earn $8 per hour teaching basketball and $10 per hour teaching swimming. That's $8 for every hour on the basketball court, $10 for every hour in the swimming pool. Let x represent the amount of time in hours that you teach basketball. So we'll make that b and x. And y will represent the amount of time in hours we spend swimming. Your goal is to earn at least, and we know that at least means greater than or equal to. So this is the total we're going to earn for basketball, $8 for every hour we coach. And this is the total we're going to earn for swimming, $10 for each hour we coach. And we want that to total up to be greater than or equal to $200. So that's our inequality. Now we need to graph that inequality. So let's use our intercept method. We want to find what x equals when y is 0. In other words, if I do 0 hours coaching swimming, how many hours will I have to work in order to make $200 just by coaching basketball? So we get 8x equals 200, and dividing both sides by 8 tells us x equals 25. So that's our x-intercept. So let's plot that on the graph. Let's make every 4 spaces 10 hours. You know what? We got more room than that. Let's make every 5 spaces 10 hours. That was good. We'll go with that. So that means that 25 is halfway between 20 and 30. There's our x-intercept. Now, we want to find our y-intercept. So we plug in 0 for x. So this will represent how much time we have to spend coaching swimming in order to make the $200 if we spend 0 time here on the basketball court. So that leaves us with 10y equals 200, and I will need 20 hours coaching swimming if we spend 0 time on the basketball court. So that's our y-intercept. Let's make a similar scale on our y-axis. And our line is what we get when we connect those 2 points. And we can use a solid line because we have greater than or equal to. And we don't need to go into the negative areas because we can't work for a negative amount of hours. So the question is, do I want points above or below that? Well, let's try a point. How about this one here? That's the point 5, 5. If I work 5 hours at each, will that earn $200 for me? So if I plug 5, 5 into my inequality, is it a solution? 8 times 5 plus 10 times 5 is equal to 40 plus 50. Is that more than 200? Boy, my screen froze there. It's not. So when I plugged in 5 for x and 5 for y, it did not come out to be at least $200. So that means 5, 5 is not a solution. So this point is not in our solution set. That means our solution set is this area up here. Now they want us to give 3 possible combinations of hours that will allow you to meet your goal. Well, you have plenty of options because all you have to do is find a point somewhere out here. Okay? So you have to find a point in that shaded area. So we can just pick 3 random points and give those coordinates. For instance, this is 15:25. That's 15 hours coaching basketball, 25 hours coaching swimming. Or 17.5, 12.5. 17 and a half hours coaching basketball and 12 and a half hours swimming. Or 30:15. 30 hours coaching basketball and 15 hours swimming. Those are just 3 of the infinite number of solutions that we could have for our graph. Alright, let's try a couple of these problems on your own, the single variable ones, and see how you do. So I want you to graph x is less than negative, we did that one, x is less than -2, and y is less than or equal to 3. So give those a shot, and then turn the video back on and see how you did. Alright, for x is less than -2, we know that we have a vertical line at -2, and since it's less than and not less than or equal to, I want to use a dotted line because I can't include the line as part of my solution. Now the x values that are less than -2 are over here to the left. That's our solution area for x is less than -2. For y is less than or equal to 3, my y values of 3 are here. So I have a horizontal line where y is 3. And since I have less than or equal to, I'm going to use a solid line because I can include that line as my solutions. Now, where are the y values less than or equal to 3? Down here. This is my solution area. So that's how I graph it when there's only one variable in my inequalities. If you have any questions, feel free to ask. If not, you can go ahead and move on to your homework.